All right, so today, strictly dealing with right triangles that have a 90-degree angle in them. So we're going to start with tangent, but we'll have dealt with sine, cosine, and tangent by the end of today. So a tangent means we're going to have an opposite over adjacent angle. Well, what does that mean necessarily? If I've got myself a right triangle, I'm going to be given a lot of times some sort of an angle that I'm working with. Because let's say, for instance, I had my angles marked A, B, and C. I'd have to have a reference angle that I'm working with to know what sides I have. So let's just say I either tell you or I have this marking that says, and that little circle with a line through it's just a Greek letter, it's called theta. We use that sometimes just to mark an angle instead of using X or some other letter. But then I can mark off my sides based on this. The one side that's never going to move is the hypotenuse, the longest side. And the longest side's always across from the largest angle, which is my right angle here. Okay, so my hypotenuse is always going to be opposite from my right angle. My other two sides, though, opposite and adjacent, well, that depends on where my reference angle is. If it's here, it makes sense that the side that's opposite from the angle would be my opposite side. And then the side that's attached to my angle, to my reference angle, would be the adjacent side. I have to keep those types of things straight, otherwise I can get myself in a little bit of a bind. So when we actually get to practice it a little bit down here below, it says write the tangent ratio as a fraction and then as a decimal for each of the following. So since they're saying it's the tangent of A, they're telling me that's my reference angle, and I'd mark it some way, either with a symbol, this way, however you want to do it. So the tangent is going to be opposite, my 4, over my adjacent side, which is 3. And we want to be interchangeable with keeping it as a fraction, which is what we'll do most of the time, or a decimal, which typically we're just going to go to 2 decimal places. We'll go to the hundredths place on this. So you might see it one way or the other, but like I said, most of the time we're going to see it in that fraction form because it's more exact. But everything bases off of the angle that you're using. Tangent of W. That would be different than if I'd had the tangent of whatever this angle would be. And again, it's always opposite over the side that's adjacent. And then here, if I type that guy in, should be right around 0.417. This may be more handy when we're actually trying to do some solving, though. So for that last one, for angle T is what I'm basing things off of. What would my fraction look like for the tangent of T? 8 over 15, opposite over adjacent. And then again, we just punch that in the calculator to get its decimal equivalent in case we decided we wanted to use that. Now, we're not always going to be given what all the sides are. Sometimes we may be given different bits of information and we're going to have to calculate the other part. But for this first part, we're just going to get used to setting it up. We'll do some solving of these in a little bit. But write the tangent ratio for each labeled angle as a fraction. Okay. If they give me an angle, because I'm not going to be using the 90 for this. So if they give me an angle, in this case, if I wanted to write the ratio, I'd have the tangent of 41. And it's going to equal the opposite over the adjacent. And we'll be solving these in a bit, but for now I just want to get you used to what the setup is going to look like. So it's always just my angle, and then I just follow the rules. Opposite over adjacent. And I could always go back and solve. And that's going to be my biggest thing with these, is just continuing to know my sides. And a lot of times I'll tell people it's not a bad idea, especially when you start trying to solve, that once you know where your reference angle is, making little tiny, bless you, little tiny notes for yourself on where the sides are so you know what you're dealing with, you know what you're working with, so I don't get the wrong trig function I'm working on. Just a thought. So, all right. So all tangent ratios for a particular size angle are the same. So in other words, if I knew this angle and I used its tangent function, I'd get the same answer back. I'd be able to figure out my size. So all of these answers are in our calculator once we get the degree measures. Here's the kicker though with calculators. And they should all be in a good mode right now because we've been doing this in my regular class. But you always want to check whenever you turn on one of these calculators. You want to go to mode, and you want to make sure your calculator isn't in the one I'm in right now. We want to be in degree when we're working with these. Because if your calculator's in radian, your answers are not going to be anywhere near what everybody else's are. So usually when I grab one of these calculators, unless it's my own of course, I'll always look and see, make sure it's in degree mode, otherwise I could get myself into a dilemma. So once that's in degree, we can get out of there. And then we can just type, to get decimal equivalents of these, what the values are. So if I want to know the tangent of 60, any triangle that had a 60-degree angle, its tangent ratio would be 1 in 732 thousandths. So sometime if we're looking to calculate again, the calculator can do this for us because, well, it just kind of gives us a shortcut. So on any of these, I can just go ahead, get myself a little bit of a head start. And yes, I can even sometimes, if I flip over here, get numbers that are sizably greater than 1. You start seeing all the ones with decimals and you start thinking they're all going to be that way, but they're not. But again, the key there, make sure we're in degree mode. We're almost to a point we actually get to start doing some calculating. Almost. So now we step it a little more. Write the tangent ratios for each pair, and then just leave them as fractions for right now. So again, the tangent of x, my baseline's right here. So you're like, well, this one's not going to make much difference because my opposite is 3, but so is my adjacent. Well, that's no fun. And then, again, you could leave it as 3 over 3 or 1 over 1, but leaving it as 3 over 3 probably is actually even the better method right now. Because again, when we do some calculating, that's actually going to help. You don't get to hear that very often with any fraction. The tangent of y, like we said, in this case, isn't going to make any difference because the opposite's still 3, and so is the adjacent. So not as big of a deal as it can be with other triangles with different sized legs. Here, it's going to make a difference. If I'm looking at angle G, what's my ratio going to be? What's my fraction? 8 over 16. But if I switch it up, and I look at it from angle T's point of view, what happens to my fraction? It flips. And again, if I get something like this, again, you can take it to a more reduced form. Now, with the whole numbers, that actually might help some. Because if I'm looking for sides, sometimes I might be able to see a pattern. So you're like, okay, so if it just flips or just takes its reciprocal, really, once I find this first one, using opposite over adjacent, I just know the other one by flipping it over. Nothing that's going to be too terribly awful. You're like, okay, this is like easy so far. This isn't bad at all. We'll start challenging you a little more here. All right. Now we're going to write the equation, but we're actually going to solve, and we're going to round our answers to the nearest tenth. So they're going to give me a reference angle. These are all going to be tangents for this first part. We'll start mixing them up here in a little bit. So like we did on the front, I'm going to take the tangent of that reference angle, and then I'm going to set it equal to opposite over adjacent. And when I do that, now my job is to solve for x. So what's my one step to get x on a side by itself? Multiply by 100. Okay, so that goes away. My x is going to be whatever 100 times the tangent of 30 is. Swing that out of the way. Not one tangent. No. That's better. And since we're going to the nearest tenth, looks like our side length to be about 57.7. So whenever we're doing any of these, and we'll do a couple of them up here before we'll get you into some of the mixes. I always, again, want to look at my sides in reference to my angle, opposite and adjacent, so we know it's going to be tangent. We've got opposite over adjacent. And you'll start to see that sometimes when I'm looking for the opposite side, there's a pattern. You're like, hey, I'm just multiplying by whatever the other side they give me is. Now that's true to a point, but you've got to be careful that the pattern you think you're seeing, that it works every time, because it won't. For this one, absolutely works. We can just multiply. Looks like we're at 49.5, and we go to the next one. But what happens when I set it up and it's opposite over adjacent? My adjacent is what I'm looking for this time. This time x is in the denominator. Same idea runs here, except I'd have to multiply by x to get it out of the denominator. And some of you will see the pattern that develops here quickly. Well, then to get x by itself, I'm just going to divide by my tangent function. So basically what the rule ends up becoming, as we swing over here, is if I'm looking for the opposite side, like we did in 14 and 15, I can just multiply by this side. Or even if I write it out, I'll be able to visually see that. But if x ends up in the denominator, we're going to be dividing by that particular trig function to find my value. So don't get rushing so fast sometime that you kind of get messed up with that. So just so we can see that one more time here, 17. I've got opposite adjacent, so I know it's tangent. Opposite over adjacent. I can see that if I multiply both sides by x, I'm going to have to divide by this to come back. So if I start to notice that pattern, I got x in the denominator, I'm just going to divide by this. That's fine. If you're feeling more comfortable working it out like this, where you can visually see and feel more comfortable with the steps you're taking, I'm good with that too. But no matter what, if we get it into the right setup, whoops, helps if I get the divide symbol in there. There we go. Much better. So that's basically what we're doing whenever we're trying to solve for a particular side with tangent. Story problems? Oh yeah, there'll be lots of them. The nice thing about trig is there's lots of life applications, so we get to start seeing lots of different parts of that within these. So I've got a person, there's my drawing skills, standing 30 feet from a flagpole. There's my flag. Can see the top of the pole at a 35-degree angle of elevation. In other words, I'm looking upward, so that's where my angle is going to form. So label the diagram with my 30 feet. That's how far I am from the pole. And x, because again, I'm trying to figure out the height of the flagpole. So I look and I'm like, oh, it kind of looks like what we were doing up above now that I actually got the picture drawn. Opposite over adjacent. The tangent of 35 equals opposite over adjacent. Since the number's in the denominator, my x value is just going to be 30 times the tangent of 35. So it looks like we have ourselves a flagpole that's about 21 feet tall. And we go on with our lives. But again, tangent isn't the only trig function we're going to deal with. We're also going to be dealing with sine and cosine. Okay, so here's my basic trig ratios. Probably something you'd want to have a pretty good grip on to keep life simpler. So we're going to start introducing ourselves, familiarizing ourselves with all three of these. So write the three trig ratios for angle W in the following. Now when I'm looking for all of these, I'm a big fan of labeling. Opposites over here. Here's my angle that's connected, it's my adjacent, and my hypotenuse is always opposite from my right angle. At least till you get comfortable with things. Once you get comfortable, if you want to skip that and just do it in your head, that's fine. Sine is always opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, as we just got done doing a bunch of, is opposite over adjacent. And I just get those set up so when I do go to calculate something, I can. So for those of you that are going to flip back and forth, I'm going to be Mr. Smart Guy here. I'm just going to write them in at the bottom of the last page. Why I didn't do that already, I have no idea. So I'm going to go ahead and do it down here because we're going to switch up angles and see what difference that makes, or why it actually does even make a difference which angle I use. Because here's what happens. Now, this 3 side before that was my adjacent, yeah, that's my opposite now. This 4 that used to be my opposite is now my adjacent, but that's still my hypotenuse. The hypotenuse doesn't change. These guys just flip. So when I'm doing sine, now my opposite is 3, or 3 over 5. My cosine, my adjacent's now 4, so 4 over 5. And my tangent, my opposite and adjacent just switched places. I end up with 3 over 4. So I'm like, okay, got to pay attention to the angle. I get it. See where all the different sides are going to be in relationship to that angle. So understanding this is going to help us immensely when we actually start calculating over on the back. Now, I won't always tell you which one of the functions to use. I just thought it would be nice to do in here. Because you'll notice, you know, you've got opposite and adjacent. You'd know to use tangent anyway. Opposite over adjacent. And then I notice right away, well, what am I going to do to get x lone? I'm going to multiply both sides by 20. Now, I won't jump up and down and scream and yell. If this were like a homework problem and you wrote this and then wrote the answer, that's fine. But I want to see something, because if it's going wrong somewhere, I want to be able to figure out where. And if you just write the answer, that doesn't help me see what's going on here. So, looking at 10.2 there, because we're typically going to round to tenths unless you have a direction that specifically tells you otherwise. But the concept behind all of these is going to be the same. Cosine, because I have adjacent and hypotenuse. So like, okay, so the cosine is 60, is adjacent over hypotenuse. Oh yeah, when I'm dividing by x in my initial setup, it means these two guys are just going to switch places. Because I'd multiply by x and then divide by the cosine of 60 anyway. And again, if you're more comfortable doing it the way we did on the last page, whoops, you can feel free to do that. And we even get whole numbers sometimes. Not a whole lot, but occasionally. But I have to pay attention to the sides that I have based on the angle I'm given. Opposite and hypotenuse is going to be sine. So the sine of 13 degrees is opposite over hypotenuse. I notice right away the numbers in the denominator, which means I'm just going to have to multiply. So 50 times the sine of 13. X is about 11.2. And that's all you've got going on these. Use the ratio to get the initial problem set up, and then just solve it for x like you would any Algebra 1 equation. So to make sure we're doing okay here, because that's always important, I want to scroll down a little further where you're not told which ratio to use to make sure we have a grip on things here. So we're going to take a look at 29 to 31, but I want you to tell me which trig function we're up to each time. So on 29, I've got a reference angle at 32. So what sides do I have and what function are we using? Opposite over adjacent tangent. So I'm like, okay, 75 is in the bottom, so I'd multiply both sides by that. Keep life simple. Go to the nearest tenth. What about 30? Okay, 30 is going to be sine because I have opposite and I have the hypotenuse. So the sine of 15, opposite over hypotenuse. Again, I notice number in the denominator, so we're just going to be multiplying. So 86 times the sine of 15. Looks like about 22.3 meters. And one last one. 31. What have we got? What are we using? Okay, we're going to be doing cosine because I have my hypotenuse over here and I have my adjacent right here. So the cosine of 30 is adjacent over hypotenuse, and we end up with one more where we're just going to be multiplying. So 74 times the cosine of 30. And I get my x that way. So really, as long as you don't mess up the function that you're using, life's usually pretty good with these. Now there's one thing we haven't talked about yet. We keep talking about finding sides, finding sides, finding sides. Sometimes we're going to be looking for an angle. So we're going to have one little change up when we get there. So let's flip over. We're going to go flipping towards the bottom here. So like I said, I don't think we need to go overkill here. So if we have a right triangle and we know two of the sides, and we don't have any angles except the right angle, we can still use our trig ratios to figure out what missing angles are. But we need to use, as it says right here, the inverse of sine, cosine, or tangent, which show up on the calculators as a little -1 exponent of sorts. So on calculators, you're going to have to push the second button before you press that to be able to find it. So what I always do is whenever I'm looking for an angle, I just like to put these little -1s up here just to be like, oh yeah, I got to remember to make sure that shows up on my calculator, otherwise I'm not going to be getting an angle. So in other words, for this one, I'm going to hit second sine. There's my little -1, lets me know I'm doing it the right way. I'm going to punch in the decimal that they have there and hit enter. And the nice thing with angles is that, well, typically they're going to be large numbers. If I got some little tiny decimals sometime, it would help me think, yeah, something's not right here. So anytime you see a capital letter, the capital letters stand for angles, the lowercase letters stand for sides. We're going to want to do second with that and just get a little bit of practice with finding my angles. And basically the only thing I got to be careful of is that I type the right function in. Oops. To get towards angles. Let me move this, we'll get this last one in, and then we'll play with them on a couple of problems and I'll let you loose. Whoops, that's not going to help me. And again, for now, a lot of times we'll round to the whole number with angles, but occasionally we'll go to tenths too. So just make sure you kind of see the directions and follow accordingly with those. So okay, we got to find missing angles. We're going to do a couple of these, then get you rolling here. Which function are we going to use on 45 to find our mystery angle? Tangent, opposite, adjacent. So the tangent of A is 36/40. So second tangent, because I need a little -1 there, and again, typically we're going to be going to the nearest whole degree, and I can get my answer. But always look for those sides first. Adjacent, hypotenuse. I'm going to be doing cosine. Except it's B. Adjacent over hypotenuse. Get my inverse. Go to the nearest whole degree. And so on. So the assignment you're going to be working with this is that last sheet that you picked up, the worksheet packet. It'll be the last assignment for our next homework check, which is going to be Friday. 3 assignments worth. The word problems we were doing before the last unit test, that think about a plan, where you get all those weird type story problems that were more like the work problems, and then the right triangle trig practice you're getting today. Note, the evens are the assignment because I don't feel like doing overkill on this. And then if you so choose to do the odds as well, you can get some extra points in for that homework check. But again, this will be on the homework check for Friday, and then tomorrow we'll be moving into laws of trig and moving ahead a little bit.